In this lesson, eventually we're going to get to talking about sine and cosine of complementary angles, but this video is going to serve more as a refresher of some of the older stuff. But you always want to make sure, again, whenever we're in our trig unit, that if you're using your calculator, you make sure that you put it in degree mode every single time. Otherwise, your answers will be wrong. So recall, this is some prior knowledge alert. Complementary angles are two angles that add to 90 degrees. So we dealt with this a lot, but it might have been a while since we've used that vocabulary. So obviously we know that two angles add to 90, but there's a formal way of writing the complement of an angle. So if we are given an angle theta, right? Remember, theta is just a variable for a missing angle, or any angle. We can find its complement by subtracting it from 90, right? So for example, I'm going to do the first example in this table. So if our angle's theta, right, we know that the complement is 30, right? Like you can be like, okay, I know if I do 60 plus 30, I'll get 90. However, more formally, what you actually do to get 30 is you take 90 degrees and you're subtracting whatever your given angle is, right? So in this case, our theta value was 60. So that's a numerical example. A formal general way to write this formula is 90 minus theta. So again, if theta is your angle, if theta is a given angle, then its complement can be written as 90 minus theta. So we're going to go through this table. We already did this one, right? This one's going to be 90 minus 60. So then our complement would be 30. So if our given angle is 50, we would find our complement by doing 90 minus 50, and that would give us 40 degrees. If our given angle is 45, to find the complement, we would do 90 minus 45 degrees, which would give us 45. If our given angle theta is 30, to find the complement, we can do 90 minus 30, and that would give us 60 degrees. And then last but not least, if our given angle theta is 10, we can find its complement by doing 90 minus 10, and that will give us 80. So just going through this table and using this formula is something we want to make sure we're used to doing, because in this lesson we're going to kind of make some generalizations of properties, and you want to make sure you kind of understand this relationship between theta and 90 minus theta. So finding some complementary angles in right triangles. So in any right triangle that you have, right, you know that you always have one 90-degree angle. Now, what we're going to be doing is making some conclusions about the other two angles. So one, we know from prior knowledge that all angles in a triangle add to 180, right? So what that means is, in any right triangle with one of the angles, I know I already account for 90 degrees. And this is no matter what example, no matter what right triangle you draw me, I already know that I account for 90 degrees already. Which, if we didn't, then it wouldn't be a right triangle, right? So we're already accounting for 90 degrees, which means that we have 90 degrees left to account for between the other two angles in here, right? So again, in any example, no matter what your right triangles look like, what you should notice is that the sum of angles B and C, and it might not always be the same letters, but the sum of any two angles other than the right angle has to be 90 degrees. And the reason is kind of what we wrote down here, right? All angles in a triangle add to 180. We already account for 90 degrees, which means the other two angles have to add to 90. Now, in mathematical terms, we call those the two acute angles, right? So you got a 90-degree angle. The two acute angles would be the other two angles in our triangle. So those two acute angles are always complementary. And again, they're always complementary because they are adding to 90 degrees. So what we're going to be doing in the lesson, in class, and the in-class activity is making some new discoveries regarding trigonometry and regarding these two complementary angles that we're talking about. Okay, and again, remember the property, right? The two angles that are not the right angles, right? These two angles, and you can label this on your triangle as well, these must be complementary, always.